So GM guys, in the last video we spoke about connecting your fetching all the SOL tokens and SPL tokens that exist in your wallet, right, with Flutter. So we already saw the advantages of doing something like that. Right, so in today's video we're going to be talking about how you can use Jupyter. So you don't necessarily have to like make use of smart contracts every time you're trying to like do something on Solana, and you can always make use of APIs. So one way you can do this is by using the Jupyter API. Yeah, so making use of the Jupyter API, there's like various things you can do, right? So real world use cases you can actually use the Jupyter API to do. Say you're building a gaming app, and in your gaming app they can exchange tokens. You can do that with the Jupyter API. You can use it for reward token conversions, player to player trading. Basically for business applications you can do salary, allow people to pay salary in different tokens, right? Multi-currency wallets, right? For DeFi platforms you can do portfolio rebalancing, automated trading bots. Like there's like a lot of things you can do with the Jupyter API. So it basically allows you to like it's an aggregator, right? It allows you to like how it works is it looks for the best platform, right, for you to make transactions on chain. Say swap, you want to swap a token, right? And um there are different uh, that's pretty much how it works. So to do this like previously, we're going to be using this SDK, right? And there's already like a template UI that we can work with. You're going to see the link to this UI in the description. Yeah, so you can just clone it and follow along, right? It's just like going to be one function that we're going to use, so it's not going to take a lot of time. So let me do that in my terminal real quick. I'm going to do it on my desktop, right? So let's say clone. So I've cloned it now. Let's command it to that repository and open it up in VS Code. Another thing we would want to do um is to use SCRCPY so you guys can like see my debugging device like in real time. Right, so by the end, this is how the UI should look when it's running. Currently, we're not running it currently. It's just like I should I should probably like do that here so I can close the terminal. Yeah, so when we run the app, it's gonna look like that pretty much. Right, so the first one we want to do is that pub get, right, to get our dependencies. So if you check here, you can already see that the data package is already like added for us, right, from pub devs. I mean, it's recently, and I'm proud to be one of the people that worked on the package. So you don't need to like have an API key, right? It's just like a a complete version of like the Python package. It's like the exact that implementation of the Python package, right? Right, so if you're using an API key, you're gonna use like this, which is like faster, but and as like data is this is more scalable, right? But for us, we're just going to use this, but the package does it automatically, so we don't need to like stress ourselves, right? Um, yeah. So like if you add this to your if you're using .here, you add this environment variable, that means you are telling the package to like use this this, right? So if you're adding this variable, just know that you might be having errors if your API key is not correct, right? It's a very easy package. Just you create a client to interact with to interact with Twitter, with your environment variables. You then you create a request, then you pass the request in another execute function, or if you are using maybe Solana mobile client, right? Maybe you're trying to like allow user to connect their wallet, then you can just do the client the order first, then you call the execute function after, right? So this one just does it like because we have access to like the private key, right? Alright, so let's just get into it. Let me try to run it because it might take a while. Alright, so as it's running, this one is already a stateful widget, and the UI is gonna look exactly like this, right? So as it's running, let's just get into coding already. So for this one, this is the function we're going to be working in, right? Although we're going to need to define our private key variable here, right? So normally you're not supposed to like work like this, right? You're supposed to like put your private key in a controlled environment where it will not be accessible because your private key like as gives anybody that has access to your private key has access to your wallet, right? They can do anything they like with your wallet. So but in this example we're just going to be like the idea is to see how the package works, right? So you can stem like a lot of ideas from there. So what I'm going to be doing is going to be creating a variable to store my private key, right? So I'll just copy and paste the private key here safely. I'm hoping you guys don't see it. Okay, there's already a variable that should hold it. That's crazy. I'm going to cut that part out, right? So what I did is I just pasted my private key in this format. So you're going to like put your private key in here, right? And next you want to work on calling on using the swap on like allowing users to swap their token, right? I mean we don't need this input field here. We don't need it. So but I'm just going to leave it there. So the first thing we want to do is we want to remove everything in this function, right? And I don't like the unnecessary comments too. Yeah, so our app is already installing. Right, so the next thing we want to do is we'll use a try catch, right? So um let us first get the amount from let's get the amount from the text controller, right? From so the only one we're going to be using is this guy over here. So I want to make sure we trim it in case of any white spaces. Yes, so just before we do all of that, just before we do this, right? We want to so we're going to be swapping these tokens to right. So we need to like have the mint address of these tokens we want to swap, right? So once you get the mint address, I suggest you just go to this package, right? Let's see if we can yeah let's see if we can access the example right from here. So in the example of this package, right, they use .cnv. We're just going to be using the string straightforward. Right, so they define the input mint, right, and the output mint. So this is just basically telling us that okay, we want to swap two tokens. When we're trying to swap, say you are giving something and you are collecting something, right? So what you are giving here this is the mint address for Solana, right? And then this is the mint address for USDC. So you are trying to swap Solana to USDC. Take note, if you are trying to swap USDC to Solana, it will be the other way. So this EP stuff is going to be up here, and then this soul is going to be like down here, right? So if it's another token entirely, say you're trying to swap drink from Baxos code to Cube, then from here you're going to this is going to be like drink mint address which you'd have to source for get one way or the other, right? And then this one is going to be the Jupe official mint address. So this one is the amount we're trying to swap, right? So for Solana, right, one Solana is equal to like 1 billion Lambots, right? So like this has to be like 1 billion if I'm correct. So this 1 million and it's hard coded. So yeah, it's hard coded. And for USDC, I believe one USDC is 1 million, 1 million micro USDC, I think. So something like that. So yeah, and after that, they call client dot order and execute, right? Because they have access to the private key. Um, and that's just pretty much it, right? Then they get the signature from the result of calling results that they get after this feature, right? So that's pretty much how it works. I just wanted us to come here to get like the the main addresses. So we can just I mean we can just take this, we can just take this and just copy and paste it what we're doing, right? So we can use that as a guide. Um try this. So I've not defined our public key, right? But we can try to get the public key from the private key. And to do that, the package already helps us to like do that, right? So let's just create let's just create a client, um ultra API client, call it client, right? And we're going to pass in I'm gonna pass in the private key. Right. So now from this client, we can get the public key. Right. So I say client dot public key URL get public key. Right. So that works. And then let's import this to interesting. So yeah. So I've created the client for us to interact with the. Oh, I've created a client to interact with Jupyter. Right. Um. Now this is Jupyter client. Blah blah blah. Interacting with Jupyter or API exactly. So yeah, so let's still go to our example and see what they did next. Right. Right. So after that, um, yeah. So this is their client over here. They're using the API key, and they created the request. Oh, I believe we are still like encoding this. Our amount should be like our amount should be from the UI, right? Then this is like the last thing they did. Then they try to get the results. Let me just copy this and then we'll remove what we do not find necessary. So results client dot. Oh yeah, that works. Make this asynchronous, right? So we don't have logger in this, so we're not gonna be using that. And output. I've not created a variable called output, right? And currently we don't need all this login currently. Yeah, so what we just need is to just um print this to the console. I mean log it to the console, right? So we don't even need the set state, do we? I don't think we need the set state currently. Right. So I'm just gonna create a log function from there, and then so we can check the transaction on chain, right? And then all of this we do not need. Right, so that error modified name signature. The other day result signature is this. Okay. Right, so the result is like map of string and dynamic. So they had to like pick out the signature from like you know what we're gonna print the result too, so we can like see. So yeah, so it doesn't print type of map of string. Um was that okay? So for this, right, for the amount, since we know that we're just gonna be like swapping soul to USDC right here, we're not trying to swap USDC back to soul. You know what? Let's try to swap USDC back to soul, right? Let's try to. So we're swapping USDC back to soul. Yeah, and we can get the amount from this store controller here. Let's trim that. And then first of all we have to, like, because this should be taking an int, right? So we're gonna try int.try pass that. String down leading trailing white space or error now. Yeah, if not, let's just do the 1 million. Sorry. Yeah, so that works. Yeah, so let's just check it out and see if that works. So we'll try to swap one exchange. Interesting. UI has issues. Alright, you know what? Let's make use of, for some reason we can't use the UI here. Let's make use of the from controller, but we know we're swapping USDC to so already, right? So and also we do not edit. Okay, everything is already there. There's no need to, like, the implementation is currently very tacky, right? But we hope that it works. We're not even logging if there are any errors. We just want to, at the same time we can just do the wallet save, like, no mind, no mind. Let's try that again, see the error. So fail to decode signed transaction. Fail to decode signed transaction. Let's see if what's causing it is this one that we use. Let's say we try 1 million. I mean, there's not 1 million in the there's not 1 million in the yeah, because one USDC is equal to 1 million micro USDCs. Fail to decode signed transaction. Let's see if the taker is. Let's see. take a let's just try to debug it by following step by step. Uh, take a yeah, that's the correct address. So you get some sort of error. Go to decode, okay. Um, so it's calling this right. The request or increment. It's going to like log all of that. Results, how it's kind of the problem be from here. Signature, stack trace. Should we try to do this stack trace stuff? Log blah blah blah. No, we already get the error right. What if we instead of using this just pass in 1 million right here? Try to swap it. The taker is correct. Honestly, I think this is just like no. Let's revert and try to swap back. So maybe we don't even have enough of what we're trying to swap. 100k. Maybe it's just wrong error we're getting, right? Right. So we try to swap more than what we could afford. Now let's check it up and see our transaction on the blockchain. You can also see it in the wallet. Sort it on minutes, right? So we had $1 worth of USDC previously, right? Um, oh, interest did point one swap 24 seconds ago. Swap 0.1 USDC. As you can see, it happened on the Jupyter aggregator. So like there's like a lot of things you can build with this alone. Like I had an idea for let's say like say there's an influencer that tries to sell merches, right? And the influencer that tries to sell merches, you can build like maybe a pre-order platform where people can just like come list stuff that people other people can pre-order and then allow them to pay in any cryptocurrency, right? Right. This Jupiter package will be getting more relevant and more relevant. I mean, even as the chipnets start coming. Yeah, I mean, it just allows for flexibility. I mean, with anything you're building at all, I mean, on Solana, you can like definitely like using the Jupyter API will make it more flexible for your users, right? Increase maybe like a better, rich user experience. That's pretty much it.